Okay, greetings and salutations, geometry students. We're delving into our new unit, Unit 12, on everyone's favorite subject, probability. I've got the lovely Holly DeVries running the camera for me, showing off her favorite toadstool apparently. Anyway, and she's just terribly excited to be doing probabilities as well. No, she's not. Anyway, some of you, when we get to our quizzes and tests, what I encourage you is always to study for those. When I tell you I want you to study for a probability test, please do so, but I'm sure I'm going to get some responses like this. Nah, I'll just take my chances. You're welcome. A probability joke to start things off. Anyway, as you can see, the very first chapter, we're hopefully going to get through 3 chapters. It's going to be in limited time. We're going to do the best we can, but we should be all right. The first one's called 12.1, Sample Spaces and Probability. What you will hopefully learn is how to find a sample space, find theoretical probabilities, and then find experimental probabilities. So we'll be discussing the differences between those two things. So as you can read here with me, sample spaces. A probability experiment is an action or a trial that has varying results. The possible results of a probability experiment are outcomes. And gives a good example here. It says, for instance, when you roll a dice, or a die technically, right? Holly, how many sides are on a dice?
6.
6. So how many possible outcomes are there when you roll a dice?
6.
6 outcomes. 1, 2, 3, 4, 5, and 6. A collection of one or more outcomes is an event, such as rolling an odd number. The set of all possible outcomes is called a sample space. So if you roll 1 dice, your sample space is 6, because there are 6 possibilities. All right? So now it's going to make it a little more complicated, not terrible, but a little bit. It says finding a sample space. So let's decide we're going to take a coin and a dice. And I'm going to have you do an experiment, and you're going to flip a coin and roll the dice and see what you get. So clearly, when you flip a coin, you've got one of 2 options, heads or tails. And when you roll the dice, as we just said, you have 6 options, okay? 1 through 6. But if we're combining those together, then this is what your sample space looks like, as you can see right here. The sample space has 12 possible outcomes. They are listed below. So you can get the number 1 with heads or with tails, the number 2 with heads or tails, etc., all the way up through 6. So our sample space is 12, because there are 12 possible outcomes every time you flip a coin and roll 1 dice. Okay? So this one says here, monitoring progress. This is for your turn to work, so whoever's running this video, please go ahead and pause after I finish describing the experiments. We're going to pause it and give them students a chance to run it. So you're going to find the number of possible outcomes in the following 2 sample spaces and then list them all. So we have number 1, you flip 2 coins, and number 2, you flip 2 coins and roll a 6-sided dice. Okay? So those, we're looking for all those possible outcomes, and you want to list them. So go ahead and pause this now. All right, so let's work these out. Make sure I have a marker I like over there. I think I do. All right, so the first one says you flip 2 coins. Holly, what are my options there if I flip 2 coins?
Tails, tails.
Tails, tails.
Heads, heads.
Heads, heads.
Heads, tails.
Heads, tails.
Tails, heads.
And what?
Tails,
Tails,
heads.
heads. Right? Those are your 4 possible outcomes of flipping 2 coins. So our sample space is 4. Okay? So now, the next one says you flip 2 coins and roll a 6-sided dice. I'm not going to actually draw all of them out right now for the essence of time, but in the previous one, we flipped 2 coins, so these are the possible outcomes. As you can possibly imagine, for each of those outcomes, you then also have these 6 possible dice rolls. Right? And I can do this same thing, and should, for each one of those other options. So what is my sample space here, Holly, with that being the case?
24.
24, right? There's 4 options here with 6 here, so 4 times 6 is 24. Your sample space, if you flip 2 coins and roll 1 dice, is indeed 24. Okay? Pretty simple stuff. All right, and me walking back and forth is gonna be annoying, but it is what it is. All right, so now we go to what's called, remember at the beginning we said what you're gonna learn, sample space, which we just talked about, then finding theoretical versus experimental probabilities. So theoretical probabilities is the probability of an event, it's the likelihood or chance that the event will occur. Probability is always a number between 0 and 1, 0 and 1, all right? So it's always gonna be a fraction or a decimal. 0 or greater, 1 or less, nothing outside of that. And can be expressed as a decimal, a fraction, or a percent. So they have this bar just to show you if something has a 0% likelihood of occurring, obviously that means it's impossible. If it's 25%, they're saying unlikely. A 50-50, we all know what it means. You got a 50-50 shot. It means it could or could not, could go either way. 75%, they're calling it likely, and if it's 100%, then it's a certainty that it's going to happen. So these are theoretical probabilities. So the outcomes for a specified event are called favorable outcomes when all outcomes are equally likely. The theoretical probability of the event can be found using the following, as I guess we'll call this an equation if you like. This is where you should write down this in your notes. Theoretical probability is the number of favorable outcomes, and by favorable is determined by whoever the experimenter is. It doesn't mean the best outcomes, it just means what you're hoping to get, divided by the total number of outcomes. So if I were to use what we just did back over on the board here, let's just consider where we flipped 2 coins, okay? Let's say, okay, I've decided that my favorable outcomes in this experiment are gonna be, I'm gonna get 2 of the same thing, either 2 tails or 2 heads. Okay, so in this instance, Holly, what is the number of favorable outcomes that I have? Forget the dice one, just the coins.
2.
2. Either tails, tails, or head, heads. And what was my total number of outcomes? My sample space?
4.
4. So what is my probability of that happening?
2.
We could express it either as a decimal, a fraction, or a percent.
50-50.
50% chance, right? 1/2, or 0.5 or 50% chance. So that's in essence what that means. There's a little designation you should be familiar with here. The probability of an event, A, is written as P of A, and that's how you say it, P of A, okay? Just so you know when you see that's what it means. The probability of an event is known as the P of A. So finding a theoretical probability, here's an example. A student is taking a quiz, this person decides to randomly guess the answers to 4 true-false questions. He didn't study at all and decided just to guess. What is the probability of the student guessing exactly 2 correct answers? So the first step as you see here is to find the outcomes in the sample space. Let C represent a correct answer and I represent an incorrect answer. And here are your possible outcomes. Here's this table. In the left column is the total number of answers that he got correct guessing, and then the outcome would look like this as possibilities. So clearly if he got a 0, that means he got all 4 questions incorrect. That's what the I stands for, 4 I's. One outcome is that he got none right. Then if he got 1 right, here's what possible options that could look like. He got the first one correct and then missed the next 3. He missed the first one, got the next one correct and missed the last 2. He missed the first 2, got the third one, missed the last one, or he missed the first 3 and got the last one. Those are all 4 possible chances to give you just 1 correct answer. The next group is getting 2 correct answers, and they've listed all those options. I'm not going to read all of those, but those indicate again 2 questions correct, 2 questions wrong in each possibility. 3 would look like this, and then finally 4 obviously is all 4 C's. They got all 4 correct. So our sample space, how big is our sample space, Mr. Vries? How many total possible outcomes are there?
5.
Total. You got to do that, you got to count all of these. So 1 plus 4 is 5.
15.
Plus 6 is 11.
That's 6.
Plus 4 is 15. plus 1 is 16. Okay, our sample space is 16 total possibilities. What did we say we wanted? Our favorable outcomes are that C represent, we wanted to, let's see, find the exactly 2 correct, that's what it was. What is the probability of the student guessing exactly 2 correct answers? And again, those are called your favorable outcomes. You need to separate that from the fact that in your mind, a favorable outcome would be that you guessed them all correct. Favorable doesn't mean the good ones, it just means what you're looking for as you're studying this. So, we're looking for him getting exactly 2 correct. That is this middle one. There are 1, 2, 3, 4, 5, 6 out of 16, okay, which we would reduce to what fraction?
3/8.
3/8, which is, as a decimal, 0.375 or 37.5%. Okay, a little more than a third of a chance of getting 2 exactly right. So as you can see, step 2, identify the number of favorable outcomes, which I just did, which was 6 out of a total of 16. Then define the probability is what I just said right there. Okay? The sum of all the probabilities of all outcomes in a sample space is 1. And so in this one, what this means, think of it this way. We said, what is the probability of this student guessing exactly 2 correct? Is 3 out of 8. So what that means is, what is the chances of him not guessing 2 correct? Would be just be 5 out of 8. To give you a total of 8 out of 8, which is 1. Okay, so whatever, this is our favorable, the non-favorable would be whatever adds us up to 1. Okay? What they do is they call that the complement. Okay? The complement is the probability of not getting what you want, what they call not A. Okay? So that's another vocab word you need to write down in your notes. It looks like that, the way they spell it. Okay? So the complement is the probability of not getting what you're asking for. And in this one we just did, as I just said, the complement is 5/8. 3/8 was our probability of getting what we want, 5/8 is what we don't want, and that is denoted, the complement is denoted as A bar, A with a line over it. Okay, and so you would say, it would look like this would then be asking you, what is the probability of getting the complement of whatever your experiment is? All right, P A bar, the probability of A bar. And the easiest way to do that, the probability of a complement of event A can be found as this. If you know the probability of what you're wanting to do, then if you want to know what the complement is, just take 1 and minus that. And again, I know this is just a lot of vocab and words going around. It's going to be confusing to you. When you start practicing it, though, the math itself shouldn't be challenging. Just understanding the concept yet again. So let's find the probabilities of complements. So you're going to see this in this picture. Now they've taken 2 dice and they've rolled them together to see what you get. And they've listed all the possible outcomes. When you roll 2 dice together, this is a depiction of all the possible outcomes, starting with snake eyes and ending with double sixes. Okay? So find the probability of each event. Letter A says the sum is not 6. So when you add these 2 dice together, you're trying to find out what is the probability of the sum not being 6. Well, as you can see here, as you start going along, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, blah, blah, blah. There is a whole lot that are not going to add up to 6. So in certain circumstances like this, the quicker way to find it is count the complement, the ones that you aren't wanting. In other words, find how many times it adds up to 6. So the way they have it laid out in order, it's really easy to follow. I've got 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, and 5 plus 1. 1, 2, 3, 4, 5 times that when you roll 2 dice, they'll add up to 6. The total space, as we said, there are 36 possible outcomes. So Holly, what is the probability of not rolling ones that add up to 6?
30 over 36.
Almost. We said there were 5.
Oh. 31 over
31
36.
over 36, that is correct. 31 over 36. And they did that down here, the sum of it not being 6, 1 minus the sum of where it's 6, which we said was 5, and you can see 31 over 36, which is about 86%. Okay, so about 86% of the time when you roll a dice, it's going to be not adding up to 6. The next one says the sum is less than or equal to 9. Okay, so what you're now looking for is any time where it adds up to more than 9. Because again, the vast majority fit that criteria. It's quicker and easier to count the ones that don't do that. So we're looking for anything over 9. Here's 10, there's 10, there's 10, there's 11, there's 11, and there's 12. That's 1, 2, 3, 4, 5, and 6. Okay, so 6 out of 36 times it'll be 10 or higher. Well, we want to know less than or equal to 9, so we do 36 minus 10, minus 5, sorry. Let me try this one more time. Confusing myself now even. We found that there were 6 events where it was 10 or greater. That's 6 out of 36, which means 30 out of 36 are 9 or less, which is a 5 out of 6 times, which is about an 83% chance. I apologize for confusing you. Hopefully you get it. If not, I'll have this posted. You can rewatch it. But again, this is why you use the complement, because at times it's easier and quicker to count than the majority if you have a large portion you're trying to figure out. Some probabilities are found by calculating a ratio of two lengths, areas, or volumes. Such probabilities are called geometric probabilities. See, that's why it's in geometry. We have geometric probabilities. I see a painful look on Holly's face. She's like, no, please save us from this. Sorry, but here we go. This is going to hurt your head just a little bit, but it's going to pull in some of the stuff that we've already done. Okay? Yes, it's coming back to haunt you to help you answer this question. So I'll read this and I'll show the picture after. It says, you throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? So somehow you just maybe close your eyes. You live in a magical world where you close your eyes and throw it at a dartboard, and it's equally likely to hit anywhere on the dartboard. It will not hit off of the board. Okay? So here's your dartboard. So it just asked us, are you more likely to get 10 points or 0 points? Oh, nightmare of nightmares. Are you more likely, let me shade in, are you more likely when you throw this dart to get it in this zone where you get 10 points? Or more likely to get it in any of these light blue zones that are worth 0? Okay? So you randomly throw this dart, you can hit anywhere on that board. Are you more likely to hit the center or hit one of these outside areas? So guess what you get to do? Yay! You get to calculate area of partial segments. Okay? So, whichever one, when you look at this dartboard, whichever one of these has the larger area means you're more likely to hit that target, right? So as you look here, let's calculate first in the area of the little circle. What is our formula for area of a circle, Holly?
Pi r squared.
That's so brilliant of you. Pi r squared. Thank you. I'm sure the rest of you thought that immediately as well. So pi r squared is pi times 10 squared. 10 squared, of course, is 100. Times pi is easily calculated to be 314 square inches. That's the easy part. Now we need to figure out the area of these partial little light blue areas. This is where you got to go back to where we did this just recently in the past. If you want to know the area of those sections, Holly, what's the shape that surrounds the entire thing?
A square.
A square. So if we calculate the area of that square, and then subtract out the area of the circle, that will give us the area of just these blue bits. Okay? The area of the square. Well, we got to know what the length of the side of a square is. They've given us this information that each one of these segments is 3 inches. What's the length of the side of the square?
18.
18! Because this is 9, altogether, plus another 9, gives me 18 for a side. So then 18 squared, I believe 18 squared, because that's your formula for area of a square. 18 squared, I believe is 324, but let me just make sure. Yes, it is. Okay, so the square area is 324. What I'd like to now do is calculate out, oh my gosh, I really messed this up. Pause, don't pause that, pause the thought. I made a brilliantly terrible mistake, and you probably already picked up on it. You're wondering when I'm going to fix it. Now is that time. The 10 is the points. The 10 is not the radius of that circle. The radius of that circle is 3. So I need to correct, goodness gracious, this is going to be a disaster. I'm going to correct my initial calculation of my area because the radius actually of that is 3. So that is pi times 3 squared. Okay, holy mackerel. Hopefully one of you all out there, if not more of you, caught that. And if you did, kudos. Let's try this again. That's 28.3. That's the area of the pink circle. Now, the area of the square is 324. So the area of the big circle, the whole thing, that radius is 9. Okay, so I have pi times 9 squared, which is 81. So 81 times pi. And that circle's entire area is about 254 square inches. So when I subtract that out of the square, I am left with 70. Okay, so the answer to this question is you are more likely randomly throwing to hit one of the blue sections than you are the pink, because there's more area involved with the blue. Hopefully that makes sense. We'll discuss it again when I see you next, but that's the scoop on that problem. All right, here's monitoring progress. You flip a coin and roll a 6-sided dice. What is the probability the coin shows tails and the die shows a 4? Okay? And then for the next 4, you find the complement to what is listed there. In number 8, it says go back to example 4, which is the dartboard, and determine if you're more likely to get 10 points or 5 points. And then example 4, are you more likely to score points or get 0 points? Okay? So, go ahead and pause now and work on these. All right, so the first one, I'm going to go back over to the board for this one. You flip a coin and roll a 6-sided dice, which we already had that drawn out. In fact, you know what? I'm not going to draw it out. Don't need to. That's just going to take up time. That was what was shown up here. You flip a coin and roll the dice. Shown right there. Here was your options when you flipped a coin and rolled one dice, and it said, what is the probability of it? I think it was tails and the number 4. Is that right? Yep, tails and the dice shows 4. So if you go back up here to that list of the 12 possibilities, there is only one time where that occurs. Okay, where you have tails and a 4. So your probability of that is 1 out of 12. Now we go for the complements of these listed numbers, and again the formula for doing that, I know I'm zipping all over the place, but I want to remind you of it, is right here. Just take 1 minus the probability that you were given. So going back down to here, we would go 1 minus the 0.45 equals 0.55. For number 5, 1 minus 1/4. Oh my gosh, you have to subtract fractions, the horror. That's 3/4. Number 6, 1 minus 1 means 0. And number 7, 1 minus 0.03 is